As we go on to topic 3 of chapter 2, they get a little more challenging and they would take more time. So what I'm going to do is pick out some of these, give you the answers for them all, and then move from there. So for instance, what would be the strategy here in number 1? Well, I would suggest that you multiply everything by 2. So 2 there, 2 there, 2 there, 2 there. Here the 2's would cancel out, multiply through, and you get an equation without fractions. So in example 2, so we will multiply everything by 15, which is the common denominator between a 5 and a 3. So 15 there, 15 there, 15 there. Each term, nothing to cancel out here, 15x. Here the 5 would cancel out and you'd get a 3. So 3 times 3 gives us the 9. Here we cancel out the 3 and here we get a 5. 5 times x, well, 5 times 5x is 25x. So we subtract 15x from both sides, we get 10x equals 9. Divide both sides by 10, we get x equals 9/10. And the answer, by the way, for number 1 was x equals 2. All right, I started number 3 here. We'll do that one. Here our common denominator is a 2 and a 3, which gives us a 6. So here we'll cancel this out, and we're left with a 3 there. Remember, this division bar is a grouping symbol, and this is a 2 there. So we're going to get from that. So again, after distributing what we have left here, we end up with this equation without fractions. I'm going to keep my y's positive, so I'm going to add 3y. This becomes 5y. I'm going to subtract 10. This side then becomes a -1. I'm going to divide both sides by 5. Here, y is a -1/5. Okay, number 4 is straightforward. You're just going to be sure you get rid of all the parentheses, group-like terms. The same with number 5, the same with number 6. So let's set up for number 7. Okay, so we moved on. We have put the answers up again for these. Now number 4 is interesting. No solution. What might you get when you get no solution? Well, you would end up with an equation that looked like this. I didn't do it, but this is what it would look like. After you did it, the x's would cancel out, and you would have 3 equals 5. Well, is that a true statement? And the answer is no. So when you end up in your equation, solving the equation with a not true statement, then the answer is no solution. Now for number 6 over here, you would end up with something like this. Let's say 0 equals 0 after you did the steps. And in a case like that, the answer would be, or it could be 5 equals 5. As long as you end up with a true statement, then the answer is all real numbers, because any number that you put into the equation for the x on one side and the x on the other would be a solution. So all real numbers. And an example of an equation would be like this. 2x plus 3 equals 2x plus 3. Now we went over that in our lesson, but just to remind you. So whatever value you put there, if a 1 there, this becomes a 2. A 1 there becomes a 2. 5 equals 5. That's why any number that you put there and put there makes this a true statement. Okay, let's jump down to 7 now. We figured out our common denominator is going to be 35. So 7 goes into there once, and 35, it goes 5 times. 5 goes into there once, and we're left with the 7. 5 goes into there once, and we're left with the 7. 7 goes into there once, and we're left with a 5. So we multiply through, and we get then 5x plus 7 equals 7x minus 5. Notice there's no fractions anymore. That's why you chose the common denominators up here to multiply every term. So the bottoms would cancel out. You're making it sort of a larger equation, but with no fractions. It's still equivalent. So we're going to subtract 5x from here. 5x from there gives us a 2x. We're going to add 5 gives us a 12. Divide both sides by 2. That gives us a 6. Now looking at number 8, here we have a fraction again. So this is one term, this is another term. So we're going to multiply both sides by 2. And the fractions go away. But here we have a negative 1, so we change each of these signs. And then here we have a negative 3x and a negative 18. Now notice if we add 3x here and 3x there, the x's disappear, and we're left with a negative 2 equals a negative 18. Is that a true statement? And the answer is no. So for number 8, no solution. For number 9, it's all real numbers. Well, let's do one like that. So that's going to be 4a minus 4a minus 6 equals negative 6. Now notice the 4a and the 4a cancels out. So we're left with a negative 6 equals negative 6. That's a true statement. So for number 9, it's all real numbers. So no matter what number you put there and what number you put there would always make this true. For number 10, it's z equals negative 4. Now, in doing number 11, I think what you might want to do is, you look over here, you see there's 2 decimal places. Well, get rid of all the decimal places by multiplying every term by 100. So here we have to add a 0. So that would be 50h, because we're moving it over 2 decimals. Here we have to add a 0, so this would be a negative 220. Here we can move it over 2, there's not a problem. So it's going to be 25h plus 1.1. Now you might say, we didn't do anything to that decimal. That's true, because we couldn't. We just multiplied all of these, and that should make it a little easier for you. So when I distribute all this, I get this. Now I'm going to subtract 25h from here, makes that 0. 25h from there makes that 25h. Add 220 to both sides, I get this. Divide both sides by 25, I get h equals 9.9. Now again, if you're doing these, you may have to include more steps, and be careful, check your work, because the key is to get this answer when you finish. So I'm sort of summarizing and giving you a few tips, but not trying to show you all of the work that perhaps you have to do. Some will have to do less, or will do less. Some may do more. Okay, we're at the 10-minute mark here. Looking at number 15, our common denominator will be 12. So again, each term by 12. So here this cancels out, and this gives me a 4. This cancels out, and this gives me a 3. So 4 times 2x is 8x. A negative 3 times 1 is a negative 3. And this just becomes that. I'm going to subtract 8x from both sides. I get 4x equals a negative 3. Divide both sides by 4. Again, the 4's cancel out. There's my answer. Now here, recognizing this is just one term, so I'm going to use the common denominator of 3. They cancel out here, and that just stays there. So I distribute that. I get 5, and a negative 5z equals a negative 3z. I'm going to add 5z here. That gives me a 2z equals 5. Divide both sides by 2, and I get the improper fraction z equals 5/2. Okay, in these last few, they're giving us instruction. Is it all real numbers? Is it no solution? Or is the answer 0? By the way, if you get that x equals 0, that doesn't mean there is no solution. It means that x is 0. That's a good number. Now in number 20, here, these just cancel out on the first one because they're reciprocals, and that makes this a 1x there. And then 4 goes into a negative 8 twice. So we go 3 times a negative 2 is negative 6, x plus 1. Now when I subtract an x here, I subtract an x here, I get this. Is this a true statement? No, that's not true. So for this one, there's no solution. Remember, anytime you get like 5 equals 5, which is reasonable, the answer is all real numbers. And we sometimes just use the funny capital R. If x is 0, that is the answer. That's a good answer. And when we have something like this, it is no solution. Again, I didn't want to make it too long. We're going on to 13 minutes.